Welcome to you all in this session. In the last lecture, we have discussed about set, right? And as a brief recap, we have defined set as the collection of all well-defined objects. We have discussed a number of sets in the last lectures. So, whenever there are two sets, we can always talk about a kind of relationship between these two sets. Likewise, if there are two people on this earth, we can always talk about their relationship. So the next question is what? Is there any feasibility to make a kind of association or a kind of relationship in between two sets? This problem can be solved with the help of a new term which is known as the function, right? So to understand the function very clearly, first let us take the example. We know all that the area of a circle depends upon the length of the radius. So if you recall at your early classes, area A is equals to calculated by pi r square. A is the area of the circle and r is its radius. To look at this equation, what this equation represents, if r changes means if we are increasing or decreasing r, a will also increase or decrease. For example, if we take r is equals to 1, then a will be equals to what? Pi, right? Pi is a constant, whose value is either 22 by 7 or 3.14, because this is a constant number. If we take r is equals to 2, then the area will be what? 2 square means 4 pi. So what we observe from this example, that is, whenever we will increase the radius of the circle, its area will also increase. Likewise, if we will decrease it, the area will decrease. So this equation in fact establishes a kind of relationship between area and the radius of a circle. So area of a circle completely depends upon its radius, right? So this relationship in mathematics is being explained with the help of function. So a function is in fact a technical term used to represent a relationship between two variables. What is the meaning of the variable? Variable means, in mathematics you will encounter two kind of quantities. One, the constant quantities, and the other is the variable quantities. Constant quantities are those quantities which remains fixed throughout. They never changes. For example, the numbers, they never changes. On the other hand, variable quantities are those quantities which changes with the passage of time. Temperature, pressure, height of a child, weight of a child, they all are changes with the passage of time. So variable means anything which changes with the passage of time. So here area can be taken as one variable and the radius itself can be taken as another variable. So what this equation in fact represents, it represents a variable A that is known as an area which is completely dependent on the other variable r that is known as the radius of the circle. So function is in fact a technical term used to represent a relationship between variable. In other words, we can also say that the relationship, a very commercial term, mathematically we denote this relationship by using the notion of a function. So as far as the definition of a function is concerned, a number of ways a function can be defined, right? For example, I have taken here two definitions and the crux of both of these two definitions is almost same. You can choose any one of them which one you prefer, right? So a function is a relation between a set of inputs to a set of outputs, where each point, yeah, each input is related to exactly one output, right? Another way the function can also be defined as a function is a rule that associates with each value of a variable x in a certain set exactly one value of another variable y in another set, right? So what does it mean? It means set of inputs and set of outputs. These two definitions are almost same. You can understand any one of them. Input means, for example, let us take a practical example. If you are clicking any key on your computer, so by clicking the key you are giving an input. It is being processed by the machine. After processing, what we get as a display, that is known as an output. Clear? This is the best example to understand a relationship between input and output. So a number of examples are available in which we are feeding some input, we will get an output after a sort of processing. So in fact, what is here, here are the radius of a circle is taken as input. Whatever input you will give, whatever the value of r you will take, the corresponding value of a you will get. So we can say that mathematically the area is a function of the radius of a circle. Look at here an example. The area of a circle depends upon the length of its radius, and so the area is said to be a function of the radius, right? This is not the only example. A number of examples are also available. Being the students of commerce and management, you can take the price of a commodity is directly dependent on the quantity demanded in the market. So how we write it? If we write is P as a price and D as a demand, and X is the quantity demanded in the market. So X is taken as input and P is its respective price. So P is completely dependent on X, right? So X is independent. Now, in case of function, when we are writing these two terms, dependence and independence, as far as the variables are concerned, the variables can be classified in two categories. Look at here. Variable may be dependent and independent, right? Independent variable means what? A variable which is free to assume any value can be considered as independent variable. On the other hand, a variable which is dependent on any other variable is called as dependent variable. Look at here. Here A is equals to pi r square. R is independent because it's your choice whatever radius for a circle you will choose. It's your choice. But the area is not independent because whatever r you will choose for a circle, its area will be as you have chosen the value of r. So r is considered as independent variable and area A is considered as dependent variable. That is why we call it as A depends on r. In terms of function, A is a function of r, that is the radius. Likewise here, P is equals to dx. The price of a commodity is directly dependent on the quantity demanded in the market, right? So X is the quantity demanded in the market. It's an independent variable, but P depends on X. That is why we call it as P is a function of quantity demanded, that is X. Likewise, P is also a function of Sx. Sx is what? P is the price S is the quantity supplied in the market. So P depends on what? The quantity supplied in the market. Here again, P is dependent and the quantity supplied in the market is completely independent variable. Like, right? So this is how you can understand the concept of function. Simply, in a brief, function is all about a technical relationship between two variables mathematically. That's all. And how two variables are interdependent, how two variables are related to each other. Relation means if two variables are related to each other, if we will make any change in one, then the corresponding change in other must also be noticed. Okay, let us take another example or another way out to understand the concept of the function. This is a diagrammatical representation of a function. I have mentioned the source here also because I'm not highly techno savvy. That's why I have taken this figure from a source which I have mentioned here. It is very mandatory to mention the source. See, we have talked about we have talked about set in the last lectures. Set can be represented in many ways. This is also another way to represent any set. Say this is a set A. It contains A, B, C. There are three elements of the set. We will call it as a set. This is another set, say B. Their elements are 1, 2, 3, and 4. Actually, this is another way to understand the concept of function because functions are very important part of this content. So try to understand it. So 2 points you should keep in your mind before proceeding. A and B are any two different sets. Number 1, A and B may have the same number of elements or they may have different number of elements. It's immaterial how many elements A and B are having. Second thing, we have also defined about set in the last lecture. A set can be finite if it contains finite number of elements. And a set is said to be infinite if it contains infinite number of elements. So here the set may be finite or infinite, number 1. Number 2, these two sets may have the same number of elements or they may have different element. It is completely immaterial, right? Now, this is a set A, this is a set B. Now, we will define a kind of function f from A to B, right? Look at this figure carefully. What this figure shows, A is arrowing towards 1, right? It is like this. So what this indicates, mathematically, if the function f is operated on A, it converts to 1. And this is how we write it as f of A is equals to 1, right? And how we will read it? We will read it as image of A under f is equals to 1, right? Image means whenever f is being operated on A, f is being acted on A, it converts A to a new thing that is 1. And we call it as image of f under image of A under f. Likewise, B is going to say 2 and then C is going to 3, right? The image of B under f is 2. Likewise, image of C under f is 3. So how we write it? F of B is equals to 2 and f of C is equals to 3. Now look at this example and try to understand whether this is a function or not. What is the meaning of a function? A function is a rule in which every element of the first set must have a unique image in Y, or what we said, every input, set of input must have only one output, right? In both way you can understand it. So look at here, image of A under F is 1, that is unique, only one. Image of B under F is 3, that is 1, that is unique, right? Image of C under F is 3. To all the three elements A, B and C, they all are having only one image, 1, 2 and 3 in B under F. So this figure represents a function. That is why this is a function. And this is how we write it and how we read it. Image of F, image of A under F is 1. Image of B under F is 2. Image of C under F is 3. Right? Try to understand this. This is very important. I will use this concept in the next slide. Right? So take the second example. Look at here. Here image of A is 1. Right? Image of A is 1. And second thing is what? Image of B is 2 as well as 3. Now the situation has been changed. See this? This is your A, B, C, and this is your B. This is 1, 2, 3, and 4. And this is your function F, right? So what this say? Image of A is 1, right? No problem. Image of A is 1 means we will have the same thing. A of A is equals to 1. This is how we write. And how we read it? Image of A under F is 1. Yani when F is being acted or operated on A, it converts 1 as an output, right? In terms of input and output is what? A is an input, right? If F is acted on this input, we are getting only a single output as 1. You can also understand it like this. Both are same base. But here what happening? Image of B is 2 as well as image of B is 3. And image of C is 4, right? But what is the requirement? Requirement is every element of the first set must have only one output, only one image. But look at here carefully. The element B is having two images, 2 and 3. This is not possible in case of function. Only what? Every element of A must have, every element, be careful. Every element of A must have a unique image, means no element of A must left out vacant. You can have many elements which are not the images of any element of A in B, but in A you cannot have even a single element which is left out, which is not having any image in B. So this case, this is not a function. That is why we have mentioned here this is not a function. I hope you understand why this is not a function. Let us take one more example to understand it very clearly. If I use the same example, say this is your A and this is your B. Take the same thing, A, B, C, this is 1, 2, 3 and 4. For example, this is your function F, right? So image of A is 2. Image of B is also 2. And image of C is also 2. So think over this example. Do you feel or do you observe that this is an example of a function? Of course, this is a function, because what is the condition? Condition is every element of the first set that is A, must have one image in Y. This condition or this definition is satisfied here. Image of A is 2. We are having only one image 2. Of what? Of A. Image of B is 2. B is also having only one image. C is also having only one image. So all the three elements A, B, C are having only one image. That is why this is also a function, right? So next, if f is a function from a set A to a set B, then how we will write it? Look at here. If f is a function from a set A to a set B, then it is written like this. F, this colon, A rightward arrow to B. And this is how we read and this is how we write and how we read it. F is a function from the set A to a set B, right? The set A is called its domain. Yani the first set is called its domain and the set B is called its codomain, right? The fact that y is a function of a variable x is represented symbolically by the equation y is equals to fx. Now I have told you what earlier we have written images of different elements. Image of A was, here is, look at this example. Image of A is 1, image of B is 2, image of C is 3, right? This is a concrete case. Now in general, if I take the set A, this is a set B, and this is a function f, right? Take any element here x, and its image under f is f of x, that is equals to y. What is this? This is an input of the set A. When f is acted on this input, it is getting fx, that is equals to y, as an output, right? In other words, you can also say it, the image of x under f is fx. We call it as y. So this equation y is equals to fx is very important. This is how we write y is equals to fx, and how we read it, y is a function of x. This is how we read it, right? So there are many ways to write it like this. We can also write y is equals to, some people write it like this. If we take here capital F, right? It depends upon how we are denoting the function. So we will use the same symbol here, where fx is called the image of x under f and x is called its pre-image. So naturally fx is called image of x under f, right? So naturally x will called as a pre-image of x. So I hope you will understand the concept of the function. Simply, what is the meaning of the function here? Function is simply whatever input you are giving to a machine. After processing, you will get some output. But the condition is what? For every input, you must have only one output. If this condition is satisfied, then your action, your operation is called a function. If not, then this is not a function. So be careful to identify or recognize this y is equals to fx. This relation y is equals to fx is what? Y is a function of x. Here this x is called independent variable. I have told you independent variable means any variable which may assume any value, and y is called dependent variable, right? Okay. Now let us take an example to understand the concept of function more mathematically. Let here x is equals to 1, 2, 3, 4 and y is equals to 2, 4, 5, 9 up to this. This is our set y. This is our set x, right? what we want to calculate, find whether the following are functions or not, and also find the domain and range of each, right? So you have to determine whether these these two examples, they are functions or not, whether they satisfy the condition of a function or not. And be careful, before proceeding the solution, you must remember that a function means for each input you must get only one output. If this condition is satisfied, it is a function. If not, it is not a function. Solution 1. The given function is what? Fx is equals to x plus 3. This is given to us, right? Now, here x is independent variable, right? X is independent. What are the values of x? X can have 1, 2, 3, 4, 5 values, because the set x contains these 5 values, right? Y is having the values from 2 to 30 given in this set, right? Now we take x is equals to 1. Put here, this is your fx. Fx is equals to 3x plus 7. So what is the value of 1? If 1 means, put the value of x is equals to 1 here. So 3 plus 7, that is 10, right? So if x is 1, then 10 is, if x is 1, then fx is 10. What does it mean? It means the image of 1 under f we are getting as 10. The same thing. Now put x is equals to 2. So 2 into 3, 6, 6 plus 7, 13. You will get 13 here. What does it mean? If you are taking 2, the image of 2 under f is 13. Now put x is equals to 3. So if you take here 3, the image of 3 under f is 16. Right? Now put x is equals to 4. So this is 4. Image of f under f is 19. Now finally 5. Image of 5 under f is 22. To look at here, this is your set x and this will be your set y. Include all the remaining elements besides 10, 13, 16 and 22. This whole will be y, right? But what is happening here? Every element of x must have a unique image. Image of 1 is 10, that is only 1. Image of 2 is 13, that is only 1. Image of 3 is 16, that is only 1. Image of 4 is 19, that is only 1. Image of 5 is 22, that is only 1. So this satisfies the condition of a function. Therefore, this is a function, right? So we can write it as like this: f is a function from x to y, right? F is a function from x to y. Then what will happen? How we write it? Once it has become a function, then we will write it like this: f is equals to 1 to 10, 2 to 13, 3 to 16, 4 to 19, 5 to 22 is a function. Here, the first element is image, is x, and this is your image. Yani image of 1 is 10, image of 2 is 13, image of 3 is 16, image of 4 is 19, and image of 5 is 22. Take the second example. F of x is equals to x square plus 1. In the same way, this is your function. The domain here is x, codomain is y, and the range is what? All those elements of y who are the images of x. So images of x are 10, 13, 16, 19 and 22. This is here. Now take this: f of x is equals to x square plus 1. Again use the same technique. F of 1 is 2, f of 2 is 5, f of 3 is 10, f of 4 is 17, f of 5 is 26, right? It means image of 1 is 2, right, under f. Image of 2 is 5, image of 3 is 10, image of 4 is 17, image of 5 is 26. So each element is having only one image. Therefore, again, this satisfies the criteria of a function. Hence, this is a function. So we write it like this as we write earlier. Here the domain is what? Domain of f is x, codomain of f is y, and the range of f is what? Range of f, right? Range of f means all those elements of y who are images of the elements of x, right? They will be represented as range. So I think we should stop it here, and we will continue the remaining portion in the next lecture. Thank you.